We are continuing with our 5.2 notes. In this video, we're going to talk a lot about two terms that we're going to see throughout Chapter 5, and that's going to be a path and a circuit. So the two are quite similar to each other. A path is a sequence of distinct edges, each adjacent to the next, with no edge included more than once. So this is really important. We cannot travel an edge more than one time. And for a path, it must start and end at different vertices. And the length of the path is going to be the number of edges in the path. So let's just say, for example, we take this graph, and I want a path from B to G. So I'm going to start at B, and I'm just looking for adjacent edges, and I'm going to work my way over to G. All right, so if I wanted to write that path, I didn't do the same one they did here, but that path would be B, C, E, H, G. Now notice it starts and ends with different letters. That makes it a path. It has 5 letters, but it's going to have length 4 because I traveled 1, 2, 3, 4 edges. So that would be length 4. Now, if we look at the one they showed us, this one was from A to D. So I'm just going to go over the top of this. They went A to B to C to E to H to D. Now, they put commas in there, but you don't have to. And if we counted the edges, it would be 1, 2, 3, 4, 5. So it has length 5. So notice it starts and ends with different letters. There's 1, 2, 3, 4, 5, 6 letters, which tells you the length is going to be 1 less than that, which is 5. So in a path, you may go through vertices more than once, but you can't go down an edge more than once. So if you're thinking of these as streets, you can't drive down the same street twice. All right, next is a circuit. It has a very similar definition to path. It is also a sequence of distinct edges, each adjacent to the next, with no edge included more than once. So that sentence is identical to the one up here. The difference for a circuit is it must start and end at the same vertex. Okay, so you have to finish where you started. So the example they gave us here was B, C, E, H, B. So if we trace that, we're going to start at B, we're going to go down to C, then we go to E, then back up to H, and then we always have to go back to where we started on a circuit. So you'll notice on a circuit, the starting and ending letters must be the same. So we traveled a total of 4 edges, so that would be length 4. Now we have 2 specific types of paths and circuits that we're going to be working with, and these are named after the mathematician that came up with graph theory, and his name is pronounced Euler, which is not what it looks like. It looks like Euler, but it's actually Euler. And so an Euler path is going to be a path that covers all edges of the graph once and only once. So the paths we did up on example 4, there were some edges that we didn't get to. So it was a path, but it wasn't an Euler path. So an Euler path has to travel down every edge or every street, if we think about it that way. An Euler circuit is going to be a circuit that covers, I said all edges, let's do it that way. Or we can say every edge. Got to watch my grammar there. So an Euler circuit is a circuit that covers every edge of the graph once and only once. So remember, a circuit has to start and finish at the same place. And so we have some examples on the next page. So if we look at the top one, what I would like you to do is start at D and end at C. So this is going to be your path. So here's your start and here's your end. And I want to see if you can find an Euler path. So we want to go down every single edge once and only once. We want to start at D and end at C. So what I'd like you to do is pause the video, see if you can come up with one, and then when you restart it, I'll go over one of the possible solutions. All right, so hopefully you took a minute and found an Euler path. There's a lot of correct ways to do these, so yours may not look like mine. So I'm going to mark my edges as I go through to show you what order I did them in. I'm going to put numbers. So I'm going to start here. This is my first edge from D to A. My second edge was here. My third edge was here. So I'm traveling around, and you can put little arrows if you want to indicate direction. And then I'm going to come down from B to C, and that's going to be 4. Now from here I've got some choices. I'm going to go ahead and go across the bottom to 5. So notice I'm hitting that vertex again, but I can hit a vertex more than once, I just can't hit an edge. So from there I'm going to come up diagonally. That's the only edge I haven't traveled yet, so this is going to be 6. Then I'm going to come across to A, that's going to be 7. And then I'm going to go back from A to C, and that's going to be 8. Okay, so if you have the numbers, I can follow. 1, 2, 3, 4, 5, 6, 7, 8. We covered every edge once and only once. Now, this is not the only possible answer, so yours may not look like mine. Now, for the second example, I want you to do an Euler circuit. So I want you to start and end at D both times. And there's not anything special about D. You could start and end anywhere for a circuit. So pause the video, see if you can come up with a circuit, and then come back and we'll check it. All right, so for my circuit, I'm going to use my path that I made a minute ago. And I'm just going to show you, you can do it without the arrows. All right, so we went 1, 2, 3, 4, 5, 6, 7, 8. So I kind of stole my answer there, and then I just have to go down here for 9 and back up for 10. So it's okay to go through, say, vertex C more than once, but on an Euler circuit, it's about the edges, so you can only have every edge covered once. All right, so for the last one, I want you to take a minute, pause the video, and see if you can come up with either an Euler path or an Euler circuit. Okay, so pause the video, take a minute, and see what you can come up with. All right, so you may have struggled a little bit on this one. So let's just say I picked D to start at. If I'm trying to come up with a path, if I go 1, 2, 3, let's say I cover those first, and then I go up to 4. So I get back to A, and I can either go to B or I can go to C. But either place I get stuck. So if I go to B, actually I can do that one. Hold on. Where did I start? I went 1, 2, 3, 4, 5, 6. Okay. So I keep losing where I started. Where did I start? All right, let's say, maybe I started here. Maybe that's 1. 1, 2, 3, 4, 5. Okay, so I get to here and I'm stuck. I've already traveled this edge and I can't get to this one. So hopefully when you tried this, you kept getting stuck, and the only way to do it is to travel an edge more than once, and that's just not possible for this example. So on this one, we're going to say it is impossible. Now we'll talk more in the next section on how to determine by looking at it whether you have one right before you start doing all the looking.